going to take a turn to something that seems kind of out there, not relative to all the stuff we've been talking about, or something a little bit different. But really, when we talk about square root equations, they're kind of the antithesis of your quadratic equations. They're the reverse direction, where your quadratic, you're squaring your square root. Well, you're taking the square root, which are inverse operations. In any event, solving square root equations, it's not like there's 4 or 5 or 6 methods. There's one method to solving these, and they solve much easier than most quadratic equations will. All right, so let's take a look. First of all, by definition, we say any equation that contains a variable in the radicand of a square root. All right, so remember, your radicand is what's underneath your square root. If there's a variable inside that radicand, then we consider that a square root equation. Right? So all of these are examples of a square root equation. You can see obviously the square root, but that's not enough. There has to be a variable in the square root. I could give you an equation. It says x square root of 3 plus 7 square root of 2 equals 5x square root 19. There we go. You say, well, that's definitely a square root equation. That is definitely not a square root equation. And to solve this equation, which we're not going to even take a look at, but to solve this equation is really no different than how you would solve a normal algebra 1 equation, as if it were 3x plus plain old 7 equals 5x. You would solve this equation the exact same way you would solve this. We don't call this a square root equation, because when you call it a square root equation, you're using a certain set of steps in order to solve it. We're going to try to get rid of the square root using a power of 2. That's going to be the idea. But something like this, that is not a square root equation, it just happens to have square roots in it, you would definitely not want to take and square both sides of this equation. So it is important that we do have that variable in the radicand. This equation has no variables in the radicand. So you can't just say, hey, if it's got square roots, it's a square root equation. That's not true. Okay, so these are examples, and these are the ones I'm actually going to do step by step. So I think I want to do this one first, just because, and this one second. We'll save this one for last. That one's going to make us work a little bit. All right, but the idea of solving these is going to be the same every time. It's not that I have to treat this one differently than, say, 1 or 2. It's going to be the same steps. It's just this one's going to involve a little bit more effort. All right, so let's try this one first. Say you were asked to solve this square root equation. So 4 plus 3 square root of 2x minus 7 equals 19. Besides looking extremely intimidating, they really aren't that difficult to solve. So if you can get past that, step 1, pretty easy. Step 1, you must isolate the square root. Let's just put a symbol. You got to isolate the square root. So in this particular problem, we got to get this square root of 2x minus 7. Just think of this as one complete item that we got to get rid of this 4, and we got to get rid of this 3 being multiplied. So this is absolutely no different than back in algebra when you solve this equation. 4 plus 3x equals 19. How do you solve that? Well, you get x by itself. How? You subtract 4, you divide by 3. That's exactly what we have to do to isolate that square root in this case. It's just, it's not plain old x, it's the square root of 2x minus 7. So, first step, we'll subtract 4. We have 3 square root 2x minus 7 equals 19 minus 4 is 50. Then we divide both sides by 3 because that is multiplication. So you get the square root of 2x minus 7 equals 5. All right? Now we're ready to go. Step 2, huge step. Square. Again, I'm referring to a power of 2. Square both sides of the equation. That's going to get rid of our square root. When you square a square root, they cancel each other out. So what we get is the square root of 2x minus 7. We're going to take that to the second power, and just make sure you take 5, the right side, to that same power. So the idea is we're squaring a square root. We're just going to be left with the radicand. So we get the radicand. 2x minus 7 equals 5 squared is 25. The square and the square root cancel each other out, and you're left with a fairly simple equation. So in step 3, you got to solve that equation. So how do you solve that? Very easily. You'll add 7 to both sides. 2x equals 32. Divide both sides by 2, and x equals 16. Now there is one more step, and we cannot neglect it. Say, well, we got our solution. Well, we might have a solution here. The problem with solving square root equations is we might get garbage answers, right? Through no fault of our own, maybe the equation never had a solution to it. And it has to do with issues with domain. When we talk about these types of functions, square root functions, they're not identified for all real numbers on their domain. Not to get real mathematically technical, but the idea is you've got to check your answer. So check answer. You got to check it back in the original equation. So if I took 4, added 3 times the square root, 2 times, I'm saying my answer is 16. Subtract 7. I'm asking the question, does that equal 19? Well, 2 times 16 is 32. And 32 minus 7, let's calculate that radicand. 32 minus 7 is 20. 32 minus 7, I think. 25. I got it. Does that equal 19? Well, the square root of 25 I know is 5. And 3 times 5 is 15. 4 plus 15 is 19. That does check. So my solution here is what I got in step 3, 16. Right? That solves this square root equation. We have to do all 4 of these steps every single time we solve these things. Okay? Time-wise, I don't think I have enough time for this one. This one would not be, it'd be the same idea. You would subtract 7, divide by a negative 1. So you'd get the square root of x over 4 equals 6, and then take both sides to the second power. In the second step, you get x over 4 equals 6 squared, which is 36, and then you would multiply both sides by 4 to get 144. Check it. I think it does actually work. Okay. I did want to concentrate on number 3, though, so it is a little bit tougher. So, the third one, let's kind of get through this. The third one, we have to solve. We got square root 15 minus x equals x minus 3. All right. Step 1 of the process would be to isolate this square root. Well, good news. Step 1, nothing to worry about. Just put a check mark because the square root already is isolated. Okay, step 2, once that square root is isolated, we're going to take both sides to the second power. So this is worth writing out. 15 minus x. I got to take the left side to the second power, but I also have to take the right side to the second power. Now, be very careful. Some people think, well, I just have to take x to the second and 3 to the second. No, you don't. It is x minus 3 to the second, which must be written twice and FOILed out. So be very careful. Now, when we square a square root, those do cancel. So what we're going to get is 15 minus x equals, now when you square this, we do have to write this twice. And we have to FOIL that out. So x minus 3 squared is going to be x squared. Outer is minus 3x, inner is minus 3x, so I'll just save some time and say minus 6x, and then negative 3 times 3 is 9. So that's what happens when I square both sides of this equation. Okay, now, if you take a look, what you have, the equation that you're now required to solve is a quadratic equation. So, little surprise there. We got ourselves a quadratic equation. Well, I'm going to say that we cannot use the square root property, which is true because we do have a linear term. So I'm either going to go with factoring or I'm going to go with the quadratic formula. If I use either one of those methods, both methods require me to get this thing set equal to 0. So I'm going to simply move the 15 over here by subtracting it and add x to that linear term. So it's a little bit backwards, but it still works. So that would be minus 5x minus 6. Right. So now my quadratic equation is set equal to 0. And I don't think we need the quadratic formula for this because that is easy to factor. So we factor this into x minus 6, x plus 1. They have to have opposite signs, remember. So if you're thinking x minus 2, x minus 3, no. No, those add up to be negative 5. They don't multiply to be negative 6. Right, and then we set each factor equal to 0, just following the steps for solving by factoring. Using the 0 product property. So x could equal 6 or x could equal negative 1. Here's where we got to be careful. There is a step 4, and it's checking to make sure that both answers are good. All right, so step 4, we got to check. Let's start off with x equals 6. Let's see what happens. So we put in 6 here and here. We'll say the square root of 15 minus 6 equals 6 minus 3, question mark. I'm saying, is that true? I don't know. 15 minus 6 is 9. So we have the square root of 9 equals 6 minus 3. Yeah, that's a true statement. So one of the solutions for sure is 6. But is the other one negative 1? So x equals negative 1. Let's find out. Put in negative 1. We got 15 minus negative 1 equals, question mark, negative 1 minus 3. So 15 minus a negative 1 is 16. So we'll say the square root of 16 equals negative 4. You can see that that is false. So negative 1 is not a solution. In fact, there's a name for it you might remember. It's what we call an extraneous solution. E-O-U-S solution. Which means it came along for the ride, we got it as a result, but it is not a solution to the original equation. It's extraneous, it's extra, it's not a solution. Only 6 is our solution. That's why we always got to check our answers on these. So make sure you do that.